Hi to my team. Hi to my wife. My name is Steve Christians. Today I'm going to be talking about open source terrors, or the risks of open source software. This session is aimed at individuals where their company is just starting to look at open source software, and they want to better understand the risks that they need to pay attention to. And while I don't really enjoy modern horror movies, there's something about the macabre that I just find fascinating and kind of fun. And so we're going to lean into that fear for this slideshow. So I hope you're excited. Thank you. So what are we talking about? First, we'll just kind of a brief overview. We'll talk about, I'll go into basics of terminology, dependency management. We'll talk about the types of risks and then look at strategies and resources for mitigating that risk. And hopefully you'll leave with some basic action items for addressing things. So who's the voice in your head? Like I said, my name is Steve Christians. I've been into security since I was looking through photos from a DEF CON magazine. No. Photos at DEF CON from a GamePro magazine. So that was probably somewhere in the 90s. It's been a while. But I've done pen testing, application security, vulnerability management. I'm currently the application security architect at Bamboo HR. Just a random thing. My favorite job title that I ever had was pre-college days. I was working at a credit union, and for a while I was their Patriot Officer. Which basically meant I managed some software called the Patriot Officer. But it was a great title, and I loved it. My personal life, I like spending time with my family, being outdoors, getting together with friends, and board games. So, foundational stuff. Let's talk about the basics. So first, terms. So open source software is software with source code that anyone can expect, modify, and enhance. It's also referred to as FOSS, free and open source software, or simply OSS. In this sense, it's free as in the freedom to use how you like, or free as in speech. That's different from no-cost software, such as maybe Adobe Reader or Safari browser. And that's free as in beer, if you've heard those, those two terms. And let's see, how prevalent is open source software? If you're here, you probably know that it's extremely prevalent, right? There's this report, the 2024 Open Source Security and Risk Analysis Report. They surveyed over 1,000 code bases, commercial code bases from various industries. And from that, they said, okay, 96% of these code bases contained open source software. And from that, 77% of all the code originated from open source software. So these are commercial repositories. Maybe it's, a company's web app, a hospital's applications that are, running a lot of important information. And 75% of that, 77% of that could be just open source software. So open source is all over the case, all over the place. Even if your company doesn't care or doesn't know about open source, it still has a major impact on your business. So dependencies. Dependency is another term you'll hear all the time if you're talking about open source. Dependencies are libraries or pieces of code that a project uses to implement some necessary or useful functionality, right? When a software component relies on another, it's dependent. And these relationships are often visualized with dependency trees or graphs. You can see them on the slides here. You'll also see them in different package managers, maybe not as pretty. But you have both direct dependencies. So you've got your parent project that has a child or a direct dependency that it relies on. And then those direct dependencies also bring in dependencies. And those are called indirect or transitive dependencies. And so you see some very basic dependency trees here. And these can get more complex and then get really messy. So this is a dependency graph for a recent version of Kubernetes, a pretty widely used open source project. And if you're here and you're already managing open source risks, this might be one of the scariest slides in the presentation. I see a few nods. It's like dealing with this is a pain. It can be a lot of fun. It can mean job security, especially, but it can be just a huge headache. I like this illustration as the dependency graph for your company's monolithic code base, right? If you've got a monolith, if you've dealt with a monolith, look at a dependency graph and you'll be like, you might cry, you might scream, because it might look like this pile of spaghetti. And then you've got the developers, dropped out a minute. You've got the developers in the background just making merge requests to it, right? Okay, so still dependencies, open source dependencies, they're part of your development family. And they're in that family even if you're embarrassed by them, if you don't know they exist, if you don't even want to talk to them at family gatherings, they're still part of the development family. And how many dependencies are part of the average project? That kind of depends, right? So I looked at Kubernetes. It has 110 direct dependencies, 99 indirect. And this was version like 1.31.1, a very recent version. Looking at Chromium browser, there was 235 direct dependencies. Axios, a big NPM HTTP library, 3 direct, 5 indirect dependencies. But then over 100,000 NPM packages also depend on Axios. So every single one of those 100,000 packages are pulling in those dependencies that Axios depends on. Same thing for the Python request library, just 4 direct dependencies. This Fabric that I use, that's kind of an AI tool, 17 direct dependencies, 72 indirect dependencies. So if you've got a project, if you've got a project, you're pulling in some open source, you might just have a couple of dependencies. Maybe you got 5, maybe you got 7. But how many dependencies do your dependencies have? There's something to think about. So what if you have microservices or a distributed monolith architecture, right? Some things to think about. How many services are using the same dependency? Maybe you have 500 microservices as part of your ecosystem. Are 10 using the same dependency? Are 200 using the same dependency? And then are they bringing in the same version? Or are they all relying on different versions of that dependency? How many use different dependencies to achieve the same purpose, right? To serve the same function. So once you start to look at this, you might start to feel a little bit nervous. You might start to feel like, hey, this is a complex problem, right? And why do we care about all these dependencies? It's because every single one introduces risks. And risks can be scary, right? They can cause you a lot of problems, and your business especially, right? So let's talk about those risks. So first, vulnerabilities. Vulnerabilities are the worst. When you bring in dependencies, you bring in vulnerabilities. And there's a lot of things about vulnerabilities. I love this quote from the Google security blog. Most vulnerabilities are in your dependencies rather than the code you write or control directly. So even when your code is not changing, there's a constant churn in your vulnerabilities. Some get fixed, others added. So you might have a project that you say, hey, this is pretty stable. There hasn't been any merge requests to it for a year. We're fine. But the dependencies, maybe there's been 10 vulnerabilities released for the dependencies that project uses. So if those dependencies haven't been updated, you just might be more vulnerable as time goes on. Other things, exploits are generally public knowledge, at least for some subset of vulnerabilities, right? The Equifax breach was due to a widely publicized and patched struts vulnerability that was released. The patch was released 2 months before Equifax was breached. And then Log4Shell. How many of you were around, had to deal with Log4Shell, Log4j? Okay, quite a few. If not, your time will come, and eventually you'll get that sleep back. Let's see. I guess to help you feel the fear, to lean into it a little bit, let's do a little thought exercise. Let's say you've got a service and it has 200 components, 200 dependencies. That's direct and indirect. And let's say 1% of those have critical vulnerabilities. Maybe it's remote code execution, something really fun, right? So 1%, you might be like, oh, that's fine. 1% is just 2. We might need to patch 1 or 2 things. For most companies, and maybe for companies you work for, so that's one service. Some companies might have 200 services, might have 500, might have 1,000 microservices, and each of them have these 200 dependencies with different critical vulnerabilities in just 1%. That could be 100, that could be 200, that could be a lot of critical vulnerabilities that if you're not looking at these open source dependencies, at the vulnerabilities they present, it could be a big problem. So moving on, what are the other risks we need to think about are licensing risks, infringement risk. So infringement is when you or your company violates a third party's intellectual property rights. And so if the dependency that you brought in violates that IP, knowingly or not, your code violates that IP, right? Just by using that dependency. And since open source software is almost always provided free and without warranty, that means your company doesn't have any contractual protections if something happens. If whoever owns that IP says, hey, you violated my property rights, they can come after you. They can come after the 100,000 projects that violate that property because they use an open source piece of software that violated it. And there are known instances of that where people have said, hey, we're going to sue these 8,000 companies, and those companies have to deal with that. Let's also talk about license restriction risk. So license restrictions, they can put conditions on how you use the software. Okay, it's basically, and let's see, yeah, restrictions on how you use the software, and including special clauses if the software is distributed, right? They might say, hey, you've distributed the software, you now also have to provide your source code. And so if no one is paying attention to those license restrictions, such as no commercial use, the company could land in serious legal trouble, right? And there are times where, hey, if you're just using this for internal only or non-distributed software, you might be fine. But if somebody's not paying attention to these risks, you might not be fine. And the other thing to note is every single dependency has its own license. Ideally, they're all using GPL or MIT license or something that is very, very safe, right? But the other thing is those dependencies have their own license, and their dependencies have their own licenses. If nobody's paying attention, it could be problems. So if you want to present this to business leaders, right? Here's some better business terms to kind of describe that legal risk, right? Costly and time-consuming litigation could result. The The business might be forced to stop selling the product, either temporarily or permanently. The business might be forced to publicly disclose source code, right? If you're a SaaS vendor and what you're selling is just, hey, here's my software that's running, being forced to disclose your source code could be a business-ending event. If not, it could be very, very painful, right? For some of us, we might look at the source code of the companies we work for, and even if it wasn't a huge problem, we would be very embarrassed to show that source code. Okay, and finally, the big one, having to pay monetary damages if you've violated someone's IP. Okay, step away from the legal stuff. Let's talk about quality. And I tried to find a batch of good quality pictures for this. So the quality risk, there's quite a few things to consider with quality. A project might have limited or no maintenance, right? Somebody might have created this piece of open source software, and then they're like, that was fun. It was a side project. I'm not going to maintain it. Maybe you found a bug in it, and you're trying to get it fixed. You submit an MR, and they're not touching it, right? It might just sit there, and suddenly, if your company really relies on this, suddenly your company might be the new maintainer, and you probably don't want to do that, right? The other thing, there's carelessness or ignorance of licensing and security issues, right? If you don't know the maintainer, which in general you probably don't, they might allow malicious merge requests, right? If they're not paying attention, basically their software could get hacked and then distributed out to everybody that relies on that dependency. They also might not be paying attention to vulnerabilities, to licensing issues. They might be pulling in something that's got a really bad license that's not for commercial use and not to be distributed. And if they weren't paying attention and don't really care, you now inherit that risk. Okay. Other things with quality, project abandonment. I kind of covered that on the previous one. And then breaking changes, right? Somebody could say, hey, I use this project mostly for my own use or for my company's use, and I just need to, I had to push an update to fix a specific bug or to add a feature. It broke a bunch of these functions, but since we no longer use them, it's fine. I'm pushing this update, and suddenly you have to decide, okay, how do we upgrade? We need some of these new features, but all those old features are broken. So now it's going to cost us a month, 2 months of development time, something like that. And these are just things that you may have to deal with, whether you like it or not, because you're using their dependency. Okay, so if you're starting to feel worried, then congratulations and welcome to the world of open source dependency management. This is what it's all about. Dealing with that stuff on a regular basis, and figuring out how to do it, have fun, and not get stressed out. And so now that we better understand the problem, what do we do about it, right? Where do we start if we want to manage and mitigate some of these risks? First, people. Get to know people, talk to people. You want to identify who else needs to be on board and who you partner with. So some of the people you'll probably want to talk to if you're interested in addressing these risks. Legal, they're almost certainly going to be interested in the license risk. They'll likely weigh in on what type of licenses they want to disallow, what might be okay with approval, and which ones are just totally fine. They'll probably also ask about what risky or disallowed licenses are currently being used, so they can address it, right? You want somebody from security if you're not that person. The risk from vulnerabilities is likely going to be managed by security or by a vulnerability management program. And at the very least, security is going to want to weigh in on how to assess and prioritize that risk. Engineering, depending on your organization, you might be in the engineering org, you might be adjacent to it, who knows? But in many ways, engineers are the users of open source. If you're going to start telling the users, hey, you can't use this, or tell them, hey, you have to upgrade all of this, and even though they might say, well, it's not broken, it's working just fine, there's going to be issues with that, right? There's going to be concerns, and you want to include them early in the planning process. Finally, some additional potential stakeholders, IT, dev tooling, DevOps, whatever that group is called in your organization. Depending on how your organization operates, you might need to partner with them to add gates, to add tooling, to add enforcement mechanisms. So get to know people, talk to people. People are going to be keys in managing this risk. Okay, so we got people, we got processes and policies. So policy can help drive your process and also give you business justification for doing things that people in departments might not want to do, right? But if you have that business justification, if you have a policy in place, that's what a policy is key. There's, let's see, an open source policy. Open source policy is great. Get it supported, get it enforced by cross-functional stakeholders, those people that you talk to. There's some guidance. There's the OWASP SCVS project. They've got great guidance on an open source policy. And then I've got a link there to some example open source policy from about 20 different commercial companies. And then you'll also want to figure out a process to do risk assessment and prioritization. This will save you a ton of time. If you've got a kind of a defined process and documented, it helps you avoid arguing over the priority of every single item, right? And there's a lot of different options for implementing it. It can be something official, like an open source governance group or a vulnerability management program. You might use SSBC, or it could be something ad hoc. That's basically, as long as you've got something that's a documented process. It might even be just a spreadsheet where you're tracking stuff. If you've got some organization, if you don't have organization, you're not really managing the risk, right? If you've got some organization, you can start to manage things. There's also some policy templates there, so I've got multiple links if you're interested. Finally, you're going to want a platform, right? You need to manage this risk, you'll need to build a data set and then start looking through it to understand it. You want to know what the risks look like. Are there certain repositories that are more risky than others? Is there one or two or 100 libraries where if you upgraded or got rid of them, they would fix a disproportionate number of your issues? When you have that data set, you can start to pull out that information and start to plan, hey, how are we going to address things, right? You also might start looking for tools or a platform to help you do this, especially if you start with a spreadsheet. Eventually, it's going to get too big to manage with a spreadsheet. Know that whatever you choose, it's not going to be perfect. There's going to be issues. You may even grow to hate it. I can name a very specific product that I hate because I had to work with it for 6 years, but I know it inside and out. And if I had to work with it again, I'd be happy to because I know how to make it do what I want. But basically find one you can live with and move forward, right? Yeah, let's see. I've got a few tools here I've listed just to build that data set, right? You can just look through your BOM files. You can look at Dependabot if you're on GitLab. There's some built-in reports, and then there are some open source tools that can do this. OSS Review Toolkit is great. Point at a repo, and it'll say, "Hey, here's your dependency graph. Here's the versions of everything, and here's vulnerabilities." And then there's tons of commercial tools that will. Once you have that platform, you can start to manage the risk, right? And so some of the previous tools, right, include that management functionality. There's also, if if you've heard of an SCA tool, software composition analysis tool, those are for managing these types of risk. There's Sneak, SemGrep, Black Duck. There's tons of them. And there's OWASP has a nice list of tools that's pretty well updated. And it's open source, freemium, and commercial tools. Great, really great resource. Okay. So kind of wrapping up. So if you're new to this space, or your company is not looking at it, and you're saying, "Hey, how do I start this?" I'm starting from scratch. What do I do? I would say first, build a data set and find a way to present it. Right? Look through the BOM files, build a spreadsheet, grab one of those open source tools, and scan your most important repositories, your most important projects, whether maybe that's your web app, maybe that's your mobile app. Get a scan and start to look at the data set. What kind of vulnerabilities do you have? What kind of licenses do you have that are just going to be dangerous, right? And figure out a way to present it. Build a report, write a one-pager, build something so that you can show the risk to other people, so that they can easily consume, right? So you can show those stakeholders what's going on. And then you go talk to those stakeholders. Say, hey, these are risks. Who's interested in working with this? Or let's make a decision on this. What do we want to do? Do we want to address this now, or in 6 months, or in a year? And then you just work together to define a path forward. Let's see. So and really that's a wrap. Let me say, your company is almost certainly using open source software, right? If so, you're inheriting the risk from vulnerabilities, from licenses, and the overall quality of the software, but you don't have to be scared. Managing the risk is not easy, but it is possible. And if it's something that interests you, it can be very satisfying. I mean, most of us are here. A lot of us are in security because we're interested in risk in one way or another, right? And we're interested in closing off risk, in addressing risk, sometimes exploiting the risk, because that can be a lot of fun. But usually that doesn't end up in a very long career path. But this can be fun. And whether you enjoy it or not, it can give you some job security. But in the end, I encourage you to go forth, conquer, and address those open source risks, and don't be scared. Thank you.